The Generative Director. The industry standard for montage, AI cinematography, and VFX pipelines, by Ahmed Bahig and Ahmed Abdelghani. Table of contents. Timestamped. Use this table to go straight to any chapter. Each timestamp allows you to jump directly to the section you need. Chapter 1, The New Director's Chair, Fundamentals of Montage Tage. Section 1.1, Assessing the Paradigm Shift from Manual Creation to Generative Direction. Section 1.2, Navigating the Montage Interface and Configuring Your Digital Workspace. Section 1.3, The Anatomy of a Prompt, Breaking Down the Core Input Structure. Section 1.4, Executing Your First Render, From Initial Concept to Visual Output. Welcome to the seat of power. If you picked up this book, you likely sense that the ground beneath the creative industry is shifting. You are no longer just an editor, a writer, or a designer. You are stepping into a role that combines all three. In this chapter, we aren't just looking at software, we are redefining your workflow. We will strip away the mystery of generative AI and look at the mechanical reality of montage tage. By the end of these pages, you will understand the philosophy of the engine, master the interface, and render your first scene with intention. 1.1a The Universal Director, Beyond Platform Specificity. While this book utilizes montage tage as its primary engine, the core methodologies, the S.A.C. hierarchy, cinematic lighting schemas, and lens physics, are designed as a universal framework for AI cinematography. In a platform-agnostic industry, these permanent principles of visual grammar ensure your skills remain relevant regardless of whether you are outputting from montage tage or integrating assets into a professional post-production pipeline like DaVinci Resolve or Adobe Premiere. 1.1 Assessing the Paradigm Shift from Manual Creation to Generative Direction. For decades, digital creation was defined by direct manipulation. If you wanted a circle, you drew a circle. If you wanted a camera pan, you set keyframes for position and rotation. Your output was exactly equal to your manual input, limited only by your dexterity and patience. Montage tage changes the unit of labor from pixels to semantics. You are no longer painting the sunset, you are describing the physics of the light, the mood of the clouds, and the lens capturing the moment. This requires a mental shift from doing to directing. Figure. Extra detailed AI-ready prompt for AI-generated diagram showing a split composition. On the left side, labeled the operator era, a weary digital artist works on a complex wireframe mesh with hundreds of manual tools. On the right side, labeled the director era, a confident creator stands before a holographic command console, manipulating glowing streams of logic and light with simple gestures. The lighting should transition from cold, clinical blue on the left to warm, vibrant gold on the right. 8K resolution, cinematic composition. This shift can feel disorienting because it removes the tactile feedback of the mouse and keyboard. However, it replaces that feedback with speed and iteration. Your skill is no longer measured by how fast you can use the pen tool, but by how clearly you can articulate a vision. In this new paradigm, ambiguity is your enemy. The machine does not have intuition, it has probability. If you provide a vague direction, montage tage will fill in the gaps with statistical averages, resulting in generic output. Your job is to reduce the statistical variance by providing high-resolution instructions. 1.2 Navigating the montage tage interface and configuring your digital workspace. When you first launch montage tage, you will notice a departure from the cluttered toolbars of traditional NLEs, non-linear editors. The philosophy here is input-centric. The interface is designed to keep your focus on the prompt bar, which acts as your primary command line. The workspace is divided into three primary zones: the command console, the viewport, and the asset library. The command console is where 90% of your work happens. It is not just a text box, it is a context-aware environment where you stack your prompts, parameters, and reference seeds. Figure. Extra detailed AI-ready prompt for AI-generated diagram showing a clean, modern UI mock-up of the montage tage software. Dark mode aesthetic with muted charcoal background. Bottom center, a sleek, glowing input bar labeled the command console. Center screen, a large, high-fidelity viewport displaying a render of a cyberpunk city. Right side, a vertical asset library, a sidebar showing thumbnails of textures and reference images. Thin neon teal lines connect specific keywords in the input bar to elements in the viewport. UX design style, high contrast. The viewport is your feedback loop. Unlike traditional rendering which happens in the background, Montime's Tage offers near real-time previews. Configure your viewport to draft mode initially. This allows you to iterate on composition and lighting without burning computational credits on high-fidelity texture processing. Before you begin, navigate to Settings, Preferences, Model Configuration. Ensure your context window is set to maximum. This setting determines how much previous conversation or data the AI remembers. For complex storytelling, you want the model to retain as much context as possible to maintain continuity between shots. 1.3 The anatomy of a prompt, breaking down the core input structure. A prompt is not a sentence, it is code written in natural language. To get consistent results in Montime's Tage, you must structure your requests syntactically. We categorize prompt elements into four specific buckets: subject, action, environment, and technical parameters. The order of these elements matters. Montime's Tage weighs tokens at the beginning of the prompt more heavily than those at the end. If the lighting is the most critical part of your scene, place it early. If the specific camera lens is a secondary detail, place it late. Here is the foundational syntax we will use throughout this book. Subject plus adjectives, action, movement, environment, context, technical parameters. Let's break down a practical example using this formula. Subject, an elderly clockmaker, weathered face, intense focus. Action, assembling a microscopic gear mechanism. Environment, dusty Victorian workshop, shafts of sunlight through smoke. Parameters, macro lens, 85mm, photorealistic, cinematic lighting. Figure, extra detailed AI-ready prompt for AI-generated diagram showing an exploded view of a text prompt. The text of elderly clockmaker assembling gears in a dusty workshop V5 is floating in 3D space. Each section of the text is bracketed and labeled with technical terms: subject token, action token, context token, and a parameter flag. Arrows point from these text blocks to a final rendered image of the clockmaker, showing how each word directly influences a specific visual element. Infographic style, clean lines, white background. Notice the use of the double colon. In Montime's Tage, this serves as a hard separator. It tells the engine that the concepts are distinct but related. Without separators, the AI might blend concepts, perhaps making the clockmaker made of gears rather than holding them. Finally, the dash signals technical parameters. These are instructions for the engine itself, not descriptions of the image. This is where you define aspect ratios, frame rates, or stylization values. We will cover the dictionary of parameters in Chapter 3, but for now, understand that they are the settings of your virtual camera. 1 point for executing your first render, from initial concept to visual output. Theory is essential, but execution is where you learn. Let's generate a Hello World scene. We will create a simple, atmospheric establishing shot. Open your command console and ensure your cursor is blinking in the primary input field. Type the following prompt exactly as written. Imagine prompt: a solitary lighthouse on a jagged cliff, huge crashing waves, storm atmosphere, rain-slicked rocks, volumetric fog, ominous lighting R16:9 style cinematic. Press enter. Watch the viewport. You will see Montime's Tage begin the diffusion process. It starts as incoherent noise, a blur of gray and static. This is the model searching the latent space for mathematical representations of lighthouse and cliff. As the render progress bar moves, shapes will coalesce. The vertical line becomes the tower, the chaotic noise at the bottom settles into ocean waves. This is the denoising phase. The AI is refining the image, adding detail where the probability of detail is highest. Once the render is complete, do not just accept it. Analyze it. Did the luminous lighting come through? Is the aspect ratio correct? If the waves look too calm, you must return to the prompt and intensify the language, e.g., changing crashing waves to violent hurricane waves. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a horizontal timeline of an image generation process. Step 1, a square of gray static noise. Step 2, vague blurry shapes of a tower and water. Step 3, a rough painting style image. Step 4, a crystal clear, high-resolution photograph of a lighthouse in a storm. Arrows flow from left to right. The background is a dark gradient. Text labels under each step, latent noise, course structure, refinement, final output. Tech tutorial aesthetic. This loop, prompt, render, analyze, refine, is the heartbeat of the montimes tage workflow. You are not pulling a slot machine lever and hoping for a jackpot, you are sculpting with text. Your first render is rarely your final cut, but it is the foundation upon which the scene is built. Figure mind map, fundamentals of montimes taged route, the new director's chair, branch, paradigm shift, node, manual versus generative, node, directing not drawing, node, reducing ambiguity, branch, the interface, node, command console, input, node, viewport, feedback, node, asset library, resources, branch, prompt anatomy, node, subject plus adjectives, node, action plus movement, node, environment plus context, node, parameters, node, separators, smiley face, branch, first render, node, input. Prompt, node, denoising process, node, analysis loop, node, refinement.
Chapter 2, The Syntax of Sight, Mastering Prompt Structure. Section 2.1, Establishing the Hierarchy of Subject, Action, and Context. Section 2.2, Utilizing Descriptors and Modifiers to Enhance Visual Fidelity. Section 2.3, The Mathematics of Influence, Understanding Weights and Emphasis Tokens. Section 2.4, Subtractive Sculpting, Cleaning up Output with Negative Prompts. In the previous chapter, we established your role in the director's chair. You understand the philosophy of montimes tage, and you are ready to move from concept to execution. Now, we must discuss the language you will speak to the engine. Many beginners treat prompting like a Google search, a handful of keywords thrown into the void in hopes of a lucky result. But as a professional, you are not searching, you are constructing. You are writing code for light, texture, and motion using natural language as your compiler. To get consistent, high-fidelity results, you must master the syntax of sight. This is not about memorizing a dictionary of magic words. It is about understanding the structural grammar that the montimes tage engine uses to parse reality. When you control the structure, you control the output. 2.1 Establishing the Hierarchy of Subject, Action, and Context. The montimes tage engine processes prompts with a specific bias, primacy. The earlier a word appears in your prompt, the more computational weight it carries. This is why a wandering, disorganized sentence often yields a confused image. To combat this, we use a strict hierarchical structure, subject plus action plus context, S.A.C. This triad ensures the AI prioritizes the core elements of your scene before it attempts to render the environment. 1. The subject, who what this is your anchor. It must be the very first element defined. If you are rendering a cybernoir detective, do not start by describing the rain-slicked streets. Start with the detective. 2. The action, doing static images feel dead. Even in a portrait, there should be implied energy. Is the subject leaning, running, screaming, or contemplating? The verb defines the tension of the frame. 3. The context, where when once the actor and the action are locked, you build the world around them. This includes the setting, the time of day, and the environmental atmosphere. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a pyramid structure labeled the S.A.C hierarchy. The top section is labeled subject, highest priority, in bold red. The middle section is action, medium priority, in amber. The base is context, lowest priority, in cool blue. Visual arrows flow downward indicating computational focus. The background should be a clean, technical dark mode UI style. Consider the difference in how the engine interprets these two structures. Weak structure, context first. In a dark rainy alleyway at night with neon lights, a detective is holding a glowing artifact looking tired. Result: the engine prioritizes the alleyway. The detective may be small, blurry, or blended into the background details. Strong structure, S.A.C. A weary cyberpunk detective clutching a glowing artifact, leaning against a brick wall, situated in a rain-slicked neon alleyway at midnight. Result: the detective is the focal point. The action, clutching leaning, is distinct. The alleyway serves its proper role as the background. By front-loading the subject, you force tage to render the character with maximum fidelity before calculating the environment. 2.2 Utilizing descriptors and modifiers to enhance visual fidelity. Once your S.A.C. hierarchy is established, your prompt is technically functional, but it is likely aesthetically flat. This is where descriptors and modifiers come into play. These are the adjectives and technical specifications that add texture to your scene. Think of modifiers as the difference between a sketch and a photograph. A dog is a concept. A golden retriever with matted fur backlit by a sunset is a specific visual reality. However, you must avoid adjective soup, the bad habit of stringing together 12 words that mean the same thing, e.g., beautiful, gorgeous, pretty, stunning. We categorize modifiers into 3 distinct layers. Physical descriptors, materiality, age, and texture, e.g., weathered, iridescent, plush. Cinematographic modifiers, camera gear and lighting, e.g., macro lens, f1.8, harsh rim lighting, volumetric fog. Artistic style, the medium or cultural touchstone, e.g., oil painting, 3D render, Bauhaus style, shot on 35mm film. Let's refine our previous detective prompt using these layers. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison. Left side, raw prompt showing a basic, low-detail 3D model of a detective. Right side, modified prompt showing a hyper-realistic, cinematic render of the same detective with dramatic lighting and texture. Connecting lines highlight specific words like weathered skin and anamorphic lens pointing to visual improvements. The raw prompt. A weary cyberpunk detective clutching a glowing artifact. The modified prompt. A weary cyberpunk detective clutching a glowing blue artifact, heavy synthetic trench coat, scarred skin texture, shot on 35mm Kodak film, shallow depth of field, anamorphic lens flares, cyan and magenta lighting scheme. Notice the specificity. We didn't just say realistic, we defined the type of realism, 35mm film. We didn't just say clothes, we defined the material, synthetic trench coat. By referencing specific camera equipment, like an anamorphic lens, you are instructing tage to mimic the optical characteristics of that glass, including how it handles light flares and background blur, bokeh. This is how you move from generating content to crafting cinema. 2.3 The mathematics of influence, understanding weights and emphasis tokens. Words are not created equal. In a sentence, you naturally emphasize certain words to change meaning. In tage, we must do this manually using weights and emphasis tokens. The engine assigns a baseline numerical value to every token in your prompt. However, you often need to break the hierarchy we discussed in section 2.1. Perhaps the glowing artifact is small, but it is the most important story element. You need to tell the engine to pay more attention to it. Most generative systems, including tage, use a bracket or syntax system to adjust these weights. A value of 1.0 is standard. A value of 1.5 increases attention by 50%. A value of 0.5 reduces it. Syntax example, concept, weight. Let's look at how weighting shifts the composition. A cyberpunk detective 1.0, holding a glowing artifact 1.5. In this variation, the AI will likely frame the shot tighter on the artifact or increase its brightness and detail, even though the detective is the subject. The math overrides the standard sentence structure. The balancing act: be careful not to crank weights too high. A weight of word 3.0 often burns the image, creating digital noise or bizarre artifacts because the AI is trying too hard to force that concept into every pixel. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a visual heat map of a prompt. The text "a cyberpunk detective holding a glowing artifact" is displayed at the bottom. Above it, a spectral heat map shows the word artifact glowing hot red-white, while detective is a cool green, visually demonstrating how the AI distributes attention based on numerical weights. Think of weights like an audio mixing board. You cannot turn every fader to the maximum volume, or you will get distortion. If you want the drums, the artifact, to sound louder, try lowering the volume of the guitars, the background, rather than just boosting the drums until they clip. 2.4 Subtractive sculpting: cleaning up output with negative prompts. Every prompt describes what you want to see. But sometimes, the most powerful tool is describing what you don't want. This is called negative prompting. I like to call this subtractive sculpting. Imagine you are a sculptor with a block of marble. Your positive prompt outlines the figure you want to carve. The negative prompt is your chisel, chipping away the excess stone to reveal the form. Negative prompts are essential for two purposes. 1. Technical correction, removing glitches, e.g., extra fingers, text, watermarks. 2. Stylistic control, removing unwanted aesthetics, e.g., cartoon, sketch, blur. Common negative prompts: asterisk anatomy, malformed limbs, extra fingers, missing limbs, fused fingers, asterisk quality, blurry, low resolution, pixelated, JPEG artifacts, grain, asterisk style, cartoon, 3D render, drawing, black and white, if you want a photo. Here is how a negative prompt influences the final render of our detective scene. Without a negative prompt, the cyberpunk keyword might trigger mon times tage to add unwanted 2D anime elements or excessive neon clutter. Positive prompt: a weary cyberpunk detective, rain-slicked alleyway, hyperrealistic, 8K. Negative prompt: anime, cartoon, illustration, drawing, neon overload, bright daylight, smooth skin, makeup. By explicitly banning smooth skin and makeup, you force the engine to render textures like pores, scars, and stubble. You are closing the doors you don't want the AI to walk through. Mastering negative prompts allows you to define the boundaries of your aesthetic. It is the safety rail that keeps the AI's imagination aligned with your vision. Author's reflection: when I first started working with these tools, I fought against the engine. I tried to write prompts like prose, expecting the AI to understand my poetic nuance. It didn't. It gave me chaos. It wasn't until I started treating the prompt as a syntax, a structured command line, that I found my voice. Remember, structure does not kill creativity, it supports it. The S.A.C. method and the mathematics of weighting are the scaffold. Your imagination is the building. Figure Mind Map Chapter 2, The Syntax of Sight, Hierarchy. S.A.C. Subject: the anchor, action, the energy, context, the world, descriptors, physical, texture, material, cinematic, light, lens, artistic, style, medium, weights and math, emphasis, tokens, balancing values, avoiding burnout, negative prompts, subtractive sculpting, technical fixes, stylistic boundaries.
Chapter 3: Virtual Cinematography, Controlling Camera and Light. Section 3.1: Specifying lens focal lengths, apertures, and sensor types. Section 3.2: Directing camera angles and perspective for narrative impact. Section 3.3: Lighting schemas, from 3-point studio setups to atmospheric naturalism. Section 3.4: Mimicking historical film stocks and cinematic textures. In Chapter 2, we mastered the syntax, the grammar required to communicate with mon times tage. You now know how to construct a prompt that the engine understands. But understanding the words is not enough, you must also master the visual language of cinema. A prompt without cinematic direction is flat. It might technically depict a man in a suit, but it lacks the soul, the atmosphere, and the intent of a true film frame. As a creator using montage tage, you are not just a writer, you are the director of photography, DP. In this chapter, we leave the writer's room and enter the virtual studio. We will control the glass through which the audience sees your world. We will sculpt with light and apply the texture of film history to your digital creations. Let's calibrate your camera. 3.1 Specifying lens focal lengths, apertures, and sensor types. The lens is the primary filter for emotional context. In traditional filmmaking, the focal length determines not just how close you are to the subject, but how the background relates to the foreground. Montage tage simulates these optical physics with frightening accuracy. When you fail to specify a lens, the AI defaults to a flat, middle-distance perspective, roughly equivalent to a smartphone camera. This creates images that feel AI-generated because they lack optical intention. To break this, you must explicitly invoke the language of glass. The narrative power of focal length. A wide-angle lens, 16 mm, 24 mm, expands space. It makes backgrounds feel vast and subjects feel small or, if close up, dynamic and distorted. Conversely, a telephoto lens, 85 mm, 200 mm, compresses space, pulling the background closer to the subject and isolating them. Use wide angles for landscapes or to create a sense of unease and distortion in horror. Use telephoto lengths for intimate portraits or to make a character feel trapped by their environment. // prompt structure for wide-angle vs telephoto. Subject, cyberpunk detective. Action, standing in rain. Camera, shot on 16mm ultra-wide lens, distorted perspective, expanding the city background. Subject, cyberpunk detective. Action, standing in rain. Camera, shot on 135mm telephoto lens, background compression, subject isolation. Figure, a split-screen comparison diagram generated by AI. The left side shows a portrait shot with a 16mm lens, showing barrel distortion and a vast background. The right side shows the same subject shot with a 200mm lens, showing a flat face and a blurred, compressed background. High contrast, technical schematic style with focal length labels overlaid in neon blue. Controlling depth of field, aperture. Aperture controls focus. A low f-stop number, f1.2, f1.8, creates a shallow depth of field, blurring the background into creamy bokeh. A high f-stop, f11, f16, keeps everything in sharp focus. In montage tage, you don't always need to state the f-stop number numerically. You can use descriptive terms that the engine associates with those values. Technical term descriptive prompt narrative effect. Sensor size and format. The sensor implies the scale of the image. Specifying IMAX 70mm tells montage tage to render incredible detail and a massive dynamic range. Specifying Super 8mm tells it to degrade the quality, adding softness and a smaller distinct aspect ratio. 3.2 Directing camera angles and perspective for narrative impact. Where you place the camera dictates the power dynamic of the scene. If you leave the angle unspecified, montage tage usually places the camera at eye level. While safe, this is often boring. To create compelling visuals, you must move the virtual camera to positions that influence the viewer's subconscious. The psychology of height. A low-angle shot, looking up, grants power to the subject. It makes heroes look heroic and villains look insurmountable. A high-angle shot, looking down, diminishes the subject, making them appear vulnerable, weak, or overwhelmed by their surroundings. The Dutch angle and POV. Tilting the horizon line creates a Dutch angle. This introduces tension, disorientation, or madness. It is a signal to the viewer that something is off. Alternatively, the point of view, POV, shot places the viewer inside the character's head. This is incredibly effective in immersive storytelling or horror. // example, creating tension with camera angles. Subject, corporate CEO negotiating. Setting, glass boardroom. Camera, low-angle worm's eye view, looking up at CEO, imposing dominance, Dutch tilt 15 degrees to suggest corruption. Figure, a detailed technical illustration showing 3 camera positions relative to a subject, high angle, eye level, and low angle. Arrows indicate the emotional direction, dominance versus vulnerability. The style is a blueprint wireframe on a dark background. 3.3 lighting schemas, from 3-point studio setups to atmospheric naturalism. Light is the paintbrush of the cinematographer. Without defined lighting, Montime's Tage will render a scene with global illumination, a flat, even light that looks like a video game. You must choose between the precision of studio lighting and the mood of naturalism. The studio rig, control and glamour. Studio lighting is artificial and deliberate. The most common setup is 3-point lighting. 1. Key light, the main light source on the subject. 2. Fill light, softens the shadows created by the key light. 3. Backlight, rim light separates the subject from the background. In Montime's Tage, explicitly requesting rim lighting or volumetric backlighting creates a professional, high production value look. It pops the subject off the screen. Atmospheric naturalism, mood and texture. Naturalism relies on environmental sources. This includes the golden hour, warm, low sun, blue hour, twilight, or chiaroscuro, high contrast, single source. Used gobbo, goes before optics, lighting to project shadows through blinds or trees. This adds texture to the light itself, breaking up flat surfaces. // prompt for atmospheric texture. Lit by harsh sunlight streaming through Venetian blinds, creating striped shadows across the face, gobbo effect, dust motes dancing in volumetric light shafts, high contrast chiaroscuro. Figure, a photorealistic rendering of a woman's face. Half her face is in shadow, chiaroscuro. The lit side features the shadow pattern of a window frame. The diagram labels the light source direction and the negative fill on the shadow side. 3-point for mimicking historical film stocks and cinematic textures. We have defined the lens and the light. Now, we must define the medium. Digital images often look too clean. They lack the organic chaos of chemical photography. To achieve a true cinematic look, you should prompt for specific film stocks or analog artifacts. This acts as the glue that binds the pixels together into a cohesive image. Specific film stocks. Montime's Tage has been trained on millions of images tagged with camera metadata. It knows what specific film looks like. Kodak Portra 400, famous for excellent skin tones and fine grain. Warm and natural. Cinestill 800T, known for the halation effect, red glow around bright lights. Perfect for night scenes and neon. Ilford HP5, a classic black and white stock with gritty, high-contrast grain. Kodachrome, vivid, saturated, vintage colors associated with the mid-20th century. Analog artifacts. Don't be afraid to ask for imperfections. Chromatic aberration, color fringing on edges, film grain, light leaks, and motion blurs add a layer of subconscious realism. These imperfections tell the viewer's brain that the image was captured in the real world, not generated in a vacuum. / putting it all together, the cinematic prompt. Subject, 1970s detective car chase. Lens, 35mm motion picture lens. Light, harsh street lamps, neon signs reflecting on wet pavement. Texture, shot on Kodak Vision 3500T, visible film grain, subtle halation around streetlights, motion blur on background. By layering these 4 elements, lens, angle, light, and stock, you move from asking the AI for a picture to directing a scene. You are no longer accepting the default output, you are crafting a vision. Figure mind map, a mind map structure titled Virtual Cinematography. Central node branches into 4 main categories: lens, angle, light, stock. Lens branches to focal length, 16mm, 85mm, and aperture, f1.8, f11. Angle branches to low angle, power, high angle, weakness, and Dutch tilt, tension. Lighter branches to the studio, 3-point, rim, and a natural, golden hour, volumetric. Stock branches to Kodak Portrait, Cinestill, and artifacts, grain, halation. Visual style is clean, modern, dark mode UI design.
Chapter 4, Defining the Aesthetic, Art Direction and Style Transfer. Section 4.1, Invoking and Blending Specific Art Movements and Mediums. Section 4.2, Controlling Color Palettes, Grading, and Emotional Tone. Section 4.3, Managing Rendering Styles, Photorealism, 3D Render, or Illustration. Section 4.4, Using Reference Images to Guide Style Without Sacrificing Originality. In Chapter 3, we stood behind the camera, adjusting lenses and sculpting light. You now have a well-composed shot with proper exposure and depth. But look at the monitor. Does it look like a blockbuster film, a vintage Polaroid, or a high-end architectural rendering? That distinction is the domain of art direction. Art direction is the cohesive visual language that wraps around your subject and composition. It is the difference between a raw data capture and a finished piece of art. As a creator using Montime's Tage, you must step out of the cinematographer's shoes and into the role of the art director. This chapter focuses on the texture of your output. We will explore how to dictate the medium, manipulate color theory to drive emotion, and decide between the hyperreal and the stylized. We will also master the delicate balance of using reference images to guide the engine without copying them. Let's define your signature style. 4.1 Invoking and Blending Specific Art Movements and Mediums. Generative AI models are trained on the sum of human art history. They know the brushstrokes of the Impressionists, the geometry of Bauhaus, and the grit of 1990s grunge. However, the true power of Montime's Tage isn't simply mimicking a single artist, it is the alchemy of blending incompatible styles to create something new. When you invoke a style, you are defining the rules of the world. If you prompt for cyberpunk, the engine expects neon, rain, and high contrast. If you prompt for Art Nouveau, it expects organic curves and muted gold tones. To master this, you must be specific about the medium first, then the movement. 4.1.1 Defining the medium. Before you ask for a style, tell Montime's Tage what the physical object is. Is this an oil painting, a vector graphic, or a claymation model? The medium dictates how light interacts with the surface of your image. Consider the difference between these two base prompts. Prompt A. A portrait of a warrior, cinematic lighting, 85mm lens style photorealistic. Prompt B. A portrait of a warrior, heavy impasto oil paint texture, visible palette knife strokes, cracked canvas varnish style classical oil. Prompt A gives you a person. Prompt B gives you a painting of a person. By specifying impasto, thick paint application, and palette knife, you force the AI to simulate the physical ridges of paint, adding tactile depth that simple filters cannot achieve. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison. Left side, a close-up of a digital face rendered in clean, smooth vector art style. Right side, the same face rendered with thick, messy oil paint textures where the lighting catches the ridges of the paint. The diagram should be labeled medium definition to highlight surface texture differences. 4.1.2 Style Blending. The most striking results often come from style fusion, combining two disparate aesthetics. This requires a weighted approach. You want the structure of one style with the texture of another. I recommend using A, subject, plus, primary style, plus, secondary style modifier, structure. For example, mixing brutalist architecture, concrete, heavy, geometric, with candy-colored pop art, bright, soft, playful, creates a fascinating visual tension. / style fusion prompt. A towering government building, brutalist architecture, raw concrete surfaces, harsh geometric angles, infused with pop art aesthetic, pastel pink and mint green color scheme, soft studio lighting, playful atmosphere. By clashing the harsh geometry with pastel colors, you create a unique aesthetic that feels fresh because it defies historical categorization. 4.2 Controlling color palettes, grading, and emotional tone. Color is the fastest way to communicate emotion. In film, this is handled during color grading, post-production. In Montime's Tage, we must bake the grade into the generation. If you leave color to chance, the engine will usually default to realistic, neutral colors based on the subject. To take control, you need to use the language of a colorist. 4.2.1 The vocabulary of grading. Avoid generic terms like blue image. Instead, use specific film stock references or color theory terms. Term visual effect, emotional tone. 4.2.2 Palette enforcement. To force a specific color scheme, list your 2 to 3 dominant colors early in the prompt, followed by the grading style. / palette control prompt. Interior of a futuristic cockpit, cyberpunk style, color palette, cyan, magenta, and deep purple, volumetrics, cinematic color grading, high contrast, deep blacks. If the engine resists your color choices, for example, if you ask for a red ocean, you may need to increase the weight of the color keywords or use a negative prompt to remove the natural color, e.g., no blue. Figure, extra detailed AI-ready prompt for AI-generated diagram showing 3 color grading strips applied to the same landscape scene. Strip 1, desaturated bleach bypass, gray-silver tones. Strip 2, golden hour warm, gold-orange tones. Strip 3, neon cyberpunk, pink-blue tones. Labels showing the emotional keywords associated with each strip. 4.3 Managing rendering styles, photorealism, 3D render, or illustration. As we move into commercial applications, the distinction between a photo and a render becomes critical. Marketing materials often require the pristine perfection of a 3D render, while narrative storytelling benefits from the imperfections of photography. 4.3.1 The digital render look. If you are creating assets for tech, gaming, or product design, you often want the Unreal Engine look. This style implies mathematically perfect lighting and surfaces without film grain. Keywords to use: Octane Render, Unreal Engine 5, Ray Tracing, Global Illumination, CG Society, 3D Shaded, Clean Topology. / 3D Product Render. A pair of floating sneakers, abstract background, Octane Render, 8K resolution, ray-traced reflections, subsurface scattering on materials, hyper-detailed, clean 3D style. 4.3.2 The photorealistic look. Conversely, if you want the image to feel captured rather than made, you must introduce camera artifacts. Perfect images look fake. Real cameras have limitations. Keywords to use: raw photo, film grain, chromatic aberration, motion blur, depth of field, shot on 35mm, ISO 800. The inclusion of ISO 800 or film grain tells Montime's Tage to add noise to the shadows, which tricks the human eye into believing the image exists in the physical world. 4.4 Using reference images to guide style without sacrificing originality. One of the most powerful features in Montime's Tage is the ability to use an existing image as a style reference, often called image-to-image or style transfer. This allows you to feed the engine a moodboard image and say, "Make it look like this." However, the trap many creators fall into is over-reliance. If the reference influence is set too high, the AI simply remixes the original image rather than applying its style to your new idea. 4.4.1 The image weight parameter. Most engines allow you to control image weight, often IO. This determines how strictly the AI adheres to the reference. Low weight, the AI takes a vague hint of the color palette. Medium weight, the AI adopts the texture and lighting style but keeps your prompt's composition. High weight, the AI attempts to replicate the reference image's composition and subject. 4.4.2 The vibe transfer workflow. To maintain originality, use reference images that contain no subject matter related to your prompt. If you want a portrait of a woman with a rusty, industrial vibe, do not use a photo of a rusty robot as a reference. The AI might accidentally merge the robot parts into the woman's face. Instead, use a close-up photo of a rusty metal wall as your style reference. The workflow. 1. Select reference, a texture or abstract color field, e.g., a photo of neon lights blurring in rain. 2. Write prompt. Describe your subject clearly, e.g., a detective standing in an alley. 3. Apply reference. Input the texture image with a medium weight. This forces Montime's tage to map the texture of the reference onto the geometry of your prompt. This is how you achieve a consistent brand look across disparate subjects without copying content. Figure. Extra detailed AI-ready prompt for AI-generated diagram illustrating the vibe transfer concept. Left input. A photo of a messy, colorful painter's palette, no face. Middle input. Text prompt: a portrait of an elderly man. Right output. The elderly man's face rendered in the chaotic, colorful distinct strokes of the painter's palette. Arrows indicating the flow from texture plus text equals stylized output. Summary. You have now moved beyond technical prompting into true creative direction. You understand that style is not a filter you slap on at the end, it is a fundamental decision about the medium, the color story, and the rendering engine. In the next chapter, we will animate these static frames. We will explore temporal consistency and how to make these carefully crafted aesthetics move without flickering or morphing into chaos. Figure Mind Map Chapter 4, Art Direction and Style, Root, Defining the Aesthetic, Branch, 4.1 Medium and Movement, Node, Physical Medium, Leaf, Oil, Vector, Clay, Charcoal, Leaf, Adds Tactile Texture, Node, Style Fusion, Leaf, Blending Incompatible Eras, Leaf, Formula, Subject plus Structure plus Texture, Branch, 4.2 Color and Emotion, Node, Grading Terms, Leaf, Bleach Bypass, Gritty, Leaf, Teal Orange, Action, Leaf, Technicolor, Vintage, Node, Palette Control, Leaf, Hexcode Specific Hues, Leaf. Negative Prompting for Colors, Branch, 4.3 Rendering Types, Node, 3D Digital, Leaf, Octane, Unreal Engine, Leaf, Clean, Commercial Look, Node, Photorealistic, Leaf, ISO Noise, Film Grain, Leaf, Imperfections equals Reality, Branch, 4.4 Reference Images, Node, Image Weight, Leaf, Low equals Vibe Only, Leaf, High equals Composition Copy, Node, Texture Transfer, Leaf, Use abstract refs to avoid subject bleed.
Chapter 5, The Consistency Challenge, Character and World Persistence. Section 5.1, Techniques for Locking Character Identity Across Multiple Generations. Section 5.2, Seed Management Strategies for Maintaining Scene Continuity. Section 5.3, Environmental Anchoring, Keeping the Background Stable While Action Changes. Section 5.4, Creating Cohesive Wardrobes and Props for Sequential Storytelling. In the previous chapters, we mastered the individual frame. You learned to direct the camera, sculpt the light, and define the artistic texture of your output. But if you are building a narrative, a single beautiful image is not enough, you need a sequence. The greatest hurdle in generative media is not quality, it is continuity. A traditional film director casts an actor, and that actor shows up to set every day with the same face. In generative AI, however, the engine naturally wants to hallucinate a new variation of your protagonist every time you hit render. This chapter addresses the one-hit wonder problem. We are moving from generating isolated masterpieces to building cohesive, sequential storytelling. We will learn to lock identities, stabilize environments, and ensure that a red jacket in Scene 1 doesn't become a blue hoodie in Scene 2. 5.1 Techniques for Locking Character Identity Across Multiple Generations. The most fragile element in generative video is the human face. Without specific instruction, a detective in a trench coat is a concept, not a person. To turn a concept into a character, we must utilize identity anchoring. Identity anchoring in Montime's tage tells the engine to prioritize specific facial features and structural geometry over the random noise of generation. We do this by establishing a reference slot or using a specific seed strategy geared toward facial recognition. You cannot rely on adjectives alone. Describing a character as gruff, 40 years old, scar on left cheek leaves too much room for interpretation. Instead, we use a synthesized reference approach. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a character sheet workflow. The image acts as a split-screen infographic. On the left, a source anchor portrait of a woman with distinctive teal hair and cybernetic glasses. On the right, 3 different cinematic frames, 1 wide shot running, 1 close-up crying, 1 medium shot eating. Connecting lines show how facial geometry, wireframe overlay, maps perfectly from the source to the action shots. Style, tech blueprint aesthetic, high contrast neon on dark grid. 5.1.1 The reference syntax. When defining your character for the first time, you must generate a master plate. This is a neutral lighting, front-facing portrait. Once generated, this becomes your visual variable. In your prompt structure, you will reference this master plate. Here is how you structure a prompt to lock identity while changing action. // the master plate. I generate this first. Prompt, portrait of Elena, sharp jawline, messy bob haircut, photography studio lighting, neutral expression, 8K resolution, save ID, Elena_01. // the action shot, referencing the ID. Prompt, Elena_01 sprinting through a neon-lit alleyway, motion blur, panicked expression, cinematic lighting cref, Elena_01 or weight, 0.85. Note the weight parameter. If you set this to 1.0, the engine may stiffen the face to match the reference too perfectly, killing the expression. I recommend a range of 0.7 to 0.9. This allows the geometry to flex for emotional acting while retaining the structural identity. 5.2 Seed management strategies for maintaining scene continuity. While identity locking handles the who, seed management handles the how. The seed is the mathematical DNA of your image's noise pattern. If you change the prompt but keep the seed, the engine attempts to apply the new instructions to the same foundational chaos. Many creators mistakenly believe they should keep the seed fixed for an entire scene. This is a trap. If you lock the seed but change the camera angle significantly, the engine will struggle to map the old noise to the new perspective, resulting in artifacts. 5.2.1 The rolling seed technique. Instead of a static lock, use iterative variations. This involves keeping the seed for small movements and shifting it for cuts. Micro movements, same seed. Use this when the character is turning their head or the wind is blowing hair. The composition remains 90% similar. New angles, new seed. When you cut from a wide shot to a close-up, drop the seed. The noise pattern for a full body is incompatible with the noise pattern for a face. Figure, extra detailed AI-ready prompt for AI-generated diagram showing seed topology. The visual displays 2 timelines. Timeline A, bad practice, shows a static seed causing a character to glitch as they turn around. Timeline B, good practice, shows the seed number incrementing, +1, +2, as the camera angle shifts, resulting in smooth transitions. Use a wireframe landscape metaphor to represent the seed noise. Lighting, orange for bad, blue for good. Minimalist UI style. To bridge the gap between different seeds, use the coherence flag in Montime's tage. This blends the color palette and lighting data from the previous shot into the new seed, ensuring that even if the mathematics change, the atmosphere remains constant. / shot 1, seed, 1 2 3 4 5. Prompt, wide shot, Elena standing in the rain, seed 1 2 3 4 5. / shot 2, close up, new seed, but linked. Prompt, extreme close up, rain droplets on Elena's face, seed random a match tone, shot _1. 5.3 Environmental anchoring, keeping the background stable while action changes. Nothing breaks immersion faster than a shifting room. This occurs when a character walks forward, but the door behind them changes into a window. The environment must be treated as a solid stage, not a fluid dream. To solve this, we borrow a technique from traditional VFX, the plate method. Do not try to generate the character and the complex background simultaneously every single time. The engine has too many variables to juggle. 5.3.1 Background in painting and locking. First, generate your empty set. Get the lighting, the furniture, and the depth exactly right. Lock this asset. In Montaigne's tage, we use this as an environmental constraint. When you generate your character into the scene, you are effectively unmasking them over the locked background. This reduces the computational load and forces the background to persist. Figure, extra detailed AI-ready prompt for AI-generated diagram showing environmental layering. A 3D isometric view of a digital room. The background, walls, furniture, is highlighted in solid gray, locked. A transparent wireframe box creates a stage in the center where a colorful, generated character is placed. Arrows indicate that the AI generation is restricted only to the wireframe box, leaving the room untouched. Style, clean architectural rendering, soft lighting. For dynamic camera moves where the background must shift perspective, use depth map consistency. By feeding the engine a depth map of your initial environment, you constrain the 3D geometry. Prompt, Elena walking towards camera envref, apartment_bg.png a depth lock, true. This ensures that if there is a pillar on the left, it moves realistically off-screen as the camera pushes in, rather than morphing into a tree. 5 point for creating cohesive wardrobes and props for sequential storytelling. We have locked the face and the room. Now, let's look at the details. A common failure point is wardrobe drift. A complex outfit, like a vintage military jacket with gold buttons, is difficult for the AI to replicate identically across 10 different shots. The solution is simplification and tokenization. The more complex the description, the higher the variance. If you need consistency, simplify the design or rely on texture tokens. 5 point for point 1 the uniform token. Instead of describing the outfit in every prompt, define it once and assign it a variable, similar to how we handled the face. However, clothing is flexible, it folds and tears. I recommend creating a style block at the end of your prompt that remains immutable across the scene. // the style block, append to every prompt in the scene. Attire, worn leather jacket, grey t-shirt, silver pendant palette, slate, amber, black. By strictly defining the material, leather, rather than the specific cut, you allow the AI to render natural folds and movement without changing the fabric type. If you overspecify 3 buttons on the left pocket, the AI will fight to show those buttons even when the character is turned away, resulting in anatomical horrors. Trust the material definition. If you say denim, the engine knows how denim behaves in light. Consistency comes from material physics, not rigid pixel placement. Summary. Consistency is the difference between a tech demo and a film. By treating your generations as assets, locking the face, managing the seed for continuity, anchoring the environment, and tokenizing the wardrobe, you stop gambling with the slot machine and start directing the scene. You are no longer asking the computer to imagine a person, you are telling it to film your actor. In the next chapter, we will take these consistent scenes and set them in motion, diving deep into the temporal coherence of advanced video generation. Figure Mind Map Chapter 5, The Consistency Challenge, Root, Consistency, Branch, Character Identity, Leaf, Identity Anchoring, Leaf, Reference Syntax, Cref, Leaf, Weight Parameters, Branch, Seed Management, Leaf, Rolling Seed Technique, Leaf, Frozen Noise versus New Angles, Leaf, Coherence Flag, Branch, Environment, Leaf, The Plate Method, Leaf, Background Locking, Leaf, Depth Map Consistency, Branch, Wardrobe and Props, Leaf, Texture Tokens, Leaf, Material Physics over Details, Leaf, Immutable Style Blocks.
Chapter 6, Motion and Mechanics, Prompting for Video Generation. Section 6.1, Describing Camera Movement, Pans, Tilts, Tracking Shots, and Zooms. Section 6.2, Directing Character Performance and Physics-Based Interactions. Section 6.3, Controlling Temporal Flow, Pacing, Frame Rates, and Slow Motion Effects. Section 6.4, Achieving Loopability and Seamless Transitions Between Clips. In Chapter 5, we solved the puzzle of consistency, ensuring your protagonist looks the same from frame to frame. Now, we introduce the most volatile and exciting variable in the equation: time. Welcome to the fourth dimension. Up until this point, we have been photographers and painters. We have had the luxury of freezing the world to perfect a single moment. When we introduce motion, however, we lose that absolute control. We are no longer painting on a canvas, we are conducting a simulation. Moving from static generation to video generation in Montime's Tage is not just a technical step, it is a psychological one. You must accept that the engine will infer movement between your keyframes. Your job is to define the boundaries of that movement so the hallucination remains grounded in physics, not chaos. This chapter covers the mechanics of motion. We will explore how to push the camera through virtual space, direct actors who don't exist, and manipulate the flow of time itself. 6.1 Describing camera movement, pans, tilts, tracking shots, and zooms. In the realm of AI video, the camera is your primary narrator. Unlike a static image where composition guides the eye, in video, movement guides the mind. If the camera floats aimlessly, the viewer feels detached. If it moves with purpose, the viewer feels immersed. We categorize camera movement in Montime's Tage into two distinct buckets: axial rotation, the camera stays in one spot but turns, and translation, the camera physically moves through space. Confusing these two in your prompt is the #1 cause of warped geometry and motion sickness in generated video. Axial rotation, pans and tilts use these prompts when you want to reveal information without changing the perspective relationship between objects. A pan right does not reveal what is behind a tree, it only reveals what is next to it. Translation, tracking, dolly, truck, crane. This is where the magic of parallax happens. When you prompt a dolly in or tracking shot, objects closer to the lens move faster than objects in the distance. This creates depth and immersion. To control this in Montime's Tage, we use specific syntax to define the vector and the intensity. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a 3D wireframe camera cone visualization. The diagram contrasts axial rotation, camera pivoting on a tripod, vs translation, camera moving along a rail. Arrows indicate motion vectors in cyan and magenta against a dark technical grid background. High contrast, schematic style, labeled clearly. Render video. Prompt a cyberpunk alleyway, neon lights reflecting in rain puddles. Camera_move tracking_forward. Intensity 5. Smoothness high. Notice the intensity parameter. In generative video, subtlety is usually superior to speed. A fast camera movement often gives the AI less time to render coherent details, resulting in blurry textures. A slow, deliberate push-in, intensity 2 to 4, often yields the highest fidelity. When combining movements, be careful. A zoom-in, lens change, combined with a dolly-in, physical movement, creates the vertigo effect. While cinematically cool, it is difficult for current AI models to render without artifacting. Stick to one primary vector of movement until you have mastered the tool. 6.2 Directing character performance and physics-based interactions. Prompting for a still image of a man drinking coffee is easy. Prompting for a video of him taking a sip is an exercise in chaos theory. The cup might merge with his hand, or the liquid might defy gravity. To achieve believable performances, you must focus on micromovements. Generative models excel at atmospheric motion, wind in hair, blinking eyes, subtle breathing, but struggle with complex, multistage actions, like picks up gun, loads it, and fires. Instead of prompting for the entire action, prompt for the moment of the action. The less is more principle, avoid complex verbs. Instead of she runs a marathon, try she is breathing heavily, sweat on brow, slow motion running stride. You are describing the state of being, not just the action. Here is a comparison of prompt strategies for character performance. Action complexity poor prompt effective Montime's Tage prompt. Physics and weight. AI video generators often struggle with the concept of weight. Objects tend to float. To combat this, use adjectives that imply mass and resistance. Words like heavy, sluggish, rigid, or viscous help the engine calculate the physics simulation correctly. For example, if you are generating a scene of a flag waving. Prompt: a heavy velvet banner flapping in a violent gale, fabric tension, rigid folds, cinematic lighting. By specifying heavy velvet and rigid folds, you prevent the AI from rendering the flag like lightweight silk or liquid. You are dictating the material properties that the physics engine must simulate. 6.3 Controlling temporal flow, pacing, frame rates, and slow motion effects. Time is not a constant in video generation, it is a stylistic choice. The perceived passage of time changes the emotional resonance of a clip. The frame rate illusion: while monetime's tage renders at a fixed technical frame rate, usually 24 or 30 frames per second, you can prompt for the aesthetic of different frame rates. Stop motion claymation implies 12 frames per second, choppy, tactile. Soap opera news implies 60 frames per second, hypersmooth, too real. Cinematic implies 24 frames per second, with standard motion blur. Manipulating speed: slow motion is one of the most powerful tools in the AI creator's arsenal. Why? Because it reduces the amount of new information the AI has to invent per second. It allows the model to maintain higher consistency because the pixel changes between frames are smaller. Figure: extra detailed AI-ready prompt for AI-generated diagram showing a temporal timeline visualization. A horizontal bar represents 1 second of video. The top half shows real time with widely spaced keyframes. The bottom half shows slow motion with densely packed interpolated frames, glowing to indicate AI generation stability. The style is futuristic UI, dark mode with neon blue accents. If you want a highly detailed, stable shot of an explosion or a splashing wave, always prompt for slow motion. Time_dilation 0.5, 50% speed. Shutter_angle 180, standard cinematic motion blur. Conversely, time-lapses, speeding up time, are excellent for landscapes and cloud movements but dangerous for human subjects. A time-lapse of a crowd often results in ghosting or flickering figures because the AI cannot track individual people moving that fast across the frame. 6.4 Achieving loopability and seamless transitions between clips. In the age of social media and digital signage, the perfect loop is the holy grail. A video that resets seamlessly allows for infinite dwell time without breaking the viewer's immersion. The seamless loop: to create a loop in monetime's tage, the first frame and the last frame must be identical or at least visually compatible. The easiest way to achieve this is to prompt for cyclic motion. Keywords that encourage loopability: orbiting rotating flowing water pulsing neon cinematograph. There is a specific parameter in monetime's tage for this: loop_mode bounce or loop_mode seamless. The bounce mode plays the clip forward and then reverses it, boomerang style, which is a cheat code for perfect loops on water or wind. Seamless attempts to blend the end back to the start. Transitions: when moving from one generated clip to another, hard cuts can be jarring if the lighting doesn't match. As a director, you need to plan your transitions in the prompt itself. The morph cut: you can guide the AI to end a clip in a way that matches the start of the next one. This is often called matching on action or matching on shape. Clip A prompt: camera zooms into the dark pupil of the character's eye. Clip B prompt: camera zooms out from a dark tunnel. By using the visual anchor of the black circle, pupil-tunnel, you create a match cut that feels intentional and high budget. I often tell my students, don't just generate clips, generate connections. If you treat every prompt as an island, your final video will feel like a slideshow. If you plan your mechanics, movement, and transitions, you are building a cinema. Figure Mind Map Chapter 6, Motion and Mechanics, Mind Map Structure, Central Node, Motion and Mechanics, Video Generation, Branch, Camera Movement, the Narrator, Subbranch, Axial Rotation Pan, Horizontal Pivot, Tilt, Vertical Pivot, Subbranch, Translation, Parallax, Tracking Dolly, Move through space, Truck, Move alongside, Crane, Vertical Lift, Subbranch, Parameters Intensity, Subtlety Speed, smoothness branch, performance and physics subbranch, the morph. Problem solution, micromovements solution, state of being versus complex verbs subbranch, weight and mass keywords, heavy, viscous, rigid, preventing floating objects branch, temporal flow, time, subbranch, frame rate aesthetics stop motion, choppy, cinematic, 24 frames per second, motion blur, subbranch, speed control slow motion, high consistency, stability, time-lapse, landscapes, high risk for humans, branch, loops and transitions subbranch, loopability cyclic keywords, orbit, flow, pulse, bounce versus seamless modes subbranch, transitions, match cuts, shape color matching, planning connections between prompts, /figure.
Chapter 7, The Editor's Eye, Iteration, in Painting, and Refinement. Section 7.1, The Iterative Loop, Analyzing Outputs to Refine Input Logic. Section 7.2, Correcting Specific Artifacts Using Localized in-Painting Tools. Section 7.3, Expanding the Canvas, Techniques for Seamless Outpainting. Section 7.4, Upscaling Workflows for Broadcast-Ready Resolution. In Chapter 6, we unlocked the fourth dimension, allowing your creations to move and breathe. You have generated clips, scenes, and characters that feel alive. But if you pause the frame or look closely at the raw output, you will likely see the imperfections. A stray artifact, a distorted hand, or a resolution that isn't quite sharp enough for the big screen. Generating the base image is only half the battle, the rest is refinement. In traditional filmmaking, this is the post-production phase. In the world of montage tage, this is where you transition from director to editor. You must stop looking at the prompt as a wish and start treating it as a tool for surgical correction. This chapter is about control. We will move away from the slot machine mentality of hoping for a lucky generation and adopt an engineering mindset. We will learn to repair, expand, and polish your visuals until they are indistinguishable from reality. 7.1 The Iterative Loop, Analyzing Outputs to Refine Input Logic. The biggest mistake new users make is changing too much at once. When a prompt fails, the instinct is to rewrite the entire sentence. This destroys your baseline. To refine an image effectively, you must understand the iterative loop: generate, analyze, isolate, modify. Your first result is rarely the final asset, it is a sketch. Look at the output objectively. Is the lighting correct, but the composition off? Is the style perfect, but the subject looking away? You must diagnose the specific point of failure before you touch the keyboard. If the composition is wrong, do not change your lighting descriptors. If the color palette is muddy, do not add more object keywords. You must hold the successful variables constant, often by locking the seed, and modify only the failing parameter. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a flow chart of the iterative loop. The visual style is a sleek, dark mode UI schematic with neon blue and amber accents. Stage 1, raw output, thumbnail of a blurry image. Stage 2, diagnosis, magnifying glass icon highlighting specific errors. Stage 3, variable isolation, a UI slider panel where only one slider is moving. Stage 4, refined render, sharp, final image. Arrows connect the stages in a cycle. When you lock the seed, you tell montage tage to keep the DNA of the image identical while you tweak the environment. This allows you to A/B test specific words. Consider this workflow when an image is almost right but feels cluttered. / original prompt, too chaotic. Cyberpunk street market, neon signs, rain, puddles, crowd of people. Vendors selling noodles, steam, cables everywhere, 8K resolution, seed 1 2 3 4 5. If the output is too busy, do not rewrite the prompt from scratch. Simply subtract the noise while keeping the seed locked. / refined prompt, focused. Cyberpunk street market, neon signs, rain, puddles. Vendors selling noodles, steam, 8K resolution, seed 1 2 3 4 5. By removing crowd of people and cables everywhere but keeping the seed, you clean up the composition without losing the specific aesthetic layout you liked in the first place. This is scientific iteration, not guesswork. 7.2 Correcting specific artifacts using localized in-painting tools. Even the best prompts produce artifacts. Extra fingers, nonsensical text on signs, or eyes that look in different directions are common issues. In the past, this required Photoshop skills. In Montaigne's tage, we use in-painting. In-painting is the act of regenerating only a specific portion of an image while leaving the rest untouched. It relies on a mask, a selection area that tells the engine, redo this pixels, but keep everything else. The secret to successful in-painting is the context window. The AI needs to see the surrounding pixels to understand what fits in the whole you are creating. If you crop your view too tightly around a hand, the AI won't know whose arm it belongs to. The golden rules of masking. Overmask slightly, do not mask only the defect. Include a small buffer of good pixels around the error so the AI can blend the seams. Simplify the prompt. When in painting, you often need to change the prompt to describe only what goes in the masked area. Feathering. Ensure your mask has a soft edge, feathering. Hard edges result in visible seams where the noise pattern changes. Let's look at a practical example. You have a beautiful portrait of a detective, but he is holding a coffee cup that is melting into his hand. Step 1. Mask the hand and the cup entirely. Step 2. Update the prompt for the in-paint task. / wrong, don't paste the full original prompt. Cinematic shot of a detective in a trench coat, rain, holding a ceramic coffee cup. / correct, describe the patch. A hand holding a white ceramic coffee cup, detailed fingers, realistic grip. Figure. Extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison of in-painting masking techniques. Left side, type mask showing a red selection barely covering a glitchy hand, resulting in a visible seam. Right side, feathered mask showing a red selection with soft gradients extending past the hand into the coat sleeve, resulting in a seamless blend. Annotations pointing to feather radius and context area. If the fix doesn't work the first time, do not keep hitting generate. Expand your mask slightly to give the AI more context to work with. Sometimes the AI cannot fix a hand because it cannot see the shoulder. 7.3 Expanding the canvas, techniques for seamless outpainting. Outpainting is the inverse of in-painting. It allows you to extend the borders of an image, inventing new content that wasn't there before. This is vital for filmmakers who generate a 1:1 square image but need a 16:9 aspect ratio for video, or marketers who need to turn a horizontal banner into a vertical social media post. The challenge here is consistency. As you expand the canvas, Montaigne's tage must hallucinate new geometry that obeys the perspective and lighting of the original center. To achieve a seamless extension, you must ensure your prompt describes the environment, not the central subject. If your original prompt focused heavily on the character, the outpainting might try to generate another character in the empty space. The zoom out workflow. Suppose you generated a close-up of a vintage radio. You now want to see the whole room. Select Outpaint, choose the direction, left, right, top, bottom, or zoom out, all sides. Adjust the prompt, remove specific subject details and emphasize the setting. / original subject prompt. A vintage 1950s radio, wooden casing, glowing dials, macro photography. / outpainting prompt, context focused. A dusty wooden table in a 1950s living room, wallpaper background. Sunlight through window, mid-century furniture. By shifting the focus to the room, you prevent the AI from generating more radios. You guide it to build the world around the object. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the outpainting process. The center is a high-resolution square image of a futuristic helmet. Surrounding this square is a semi-transparent grid being filled in by the AI. The new areas show a sci-fi laboratory background extending seamlessly from the helmet's reflections. visual style, technical wireframe overlay transitioning into photorealistic render. Always outpaint in small increments if possible. Expanding a canvas by 400% in one go often leads to repetitive textures or warped perspective. Expanding by 50% allows you to verify the continuity of the lines and light before moving further. 7. For upscaling workflows for broadcast-ready resolution. The final step in the pipeline is upscaling. Most generative models output images between 1024px and 2048px wide. This is fine for Instagram, but unacceptable for print or 4K broadcast. However, upscaling is not just making it bigger. Traditional bicubic upscaling simply stretches the pixels, resulting in a blur. AI upscaling creates new pixels based on what it thinks should be there. This adds detail, but it comes with a risk: the waxy skin effect. Aggressive AI upscalers tend to smooth out natural textures like skin pores, film grain, or concrete grit, making everything look like plastic. As a professional, you must fight this smoothing to retain authenticity. The creative upscale. The best workflow involves creative upscaling, sometimes called upscale with reprompting. Instead of just increasing resolution, you run a very weak generation pass over the image at a higher resolution. The recipe for texture retention. Denoising strength, set this very low, 0.1 to 0.3. You want the AI to change the image slightly to add detail, but not change the composition. Prompt for texture, add keywords specifically for high-frequency detail. / upscale prompt additions. Highly detailed skin texture, film grain, rough concrete texture. 8K sharp focus, raw photograph. By explicitly prompting for grain or texture during the upscale, you force the engine to inject noise back into the clean surfaces. This breaks up the plastic look and simulates the optical physics of a high-resolution camera sensor. If you are preparing for print, always do a final pass in an external raster editor, like Photoshop, to add a uniform layer of monochromatic noise, 1 to 2%. This unifies the AI-generated pixels and the upscaled details into a cohesive visual that fools the eye into seeing film. Your role as an editor is the final line of defense. The generative engine provides the raw material, your eye provides the standard of quality. Never accept a raw generation as finished work. Iterate until the logic holds, repair the artifacts, expand the world, and polish the resolution until it stands up to professional scrutiny. Figure mind map, the editor's eye, refinement workflow, central node, refinement workflow, branch, iteration, node, lock seed, node, isolate variables, node, A/B testing, branch, in painting, node, masking, subnode, feather edges, subnode, context window, node, local prompts, subject only, branch, out painting, node, expand canvas, node, shift prompt, subject-environment, node, perspective continuity, branch, upscaling, node, creative upscale, node, low denoise, 0.1. 0.3, node, add texture, grain, node, final polish, external, figure mind map, the editor's eye, refinement workflow.
Chapter 8. Commercial Workflows, Scaling Production for Clients. Section 8.1. Building Reusable Prompt Libraries and Templates for Team Efficiency. Section 8.2. Adhering to strict brand guidelines within a generative framework. Section 8.3. Rapid storyboarding and visualization for client pitch decks. Section 8.4. Integrating montage assets into traditional VFX and editing pipelines. In Chapter 7, we operated with the precision of a film editor, meticulously refining pixels and correcting artifacts. We learned that the difference between a good generation and a usable asset lies in that final 10% of polish. Now, we must zoom out from the pixel to the pipeline. Creating beautiful images for yourself is art. Creating specific images for a client, on a deadline, with strict parameters, is business. The commercial world demands reliability over serendipity. A client does not care if the AI hallucinated something interesting if it violates their brand guidelines. In this chapter, We transition from the mindset of a solo artist to that of a production studio. We will explore how to tame the wild creative potential of Montime's Tage into a predictable, scalable workflow. This is about turning prompt engineering into a robust manufacturing process. You will learn to build systems that allow you to say yes to complex client requests without fear. We will cover the creation of modular prompt libraries, strict adherence to brand identity, and the integration of generative assets into professional post-production software. Let's get to work. 8.1 Building reusable prompt libraries and templates. When working commercially, time is your most expensive resource. Rewriting complex lighting and camera descriptions for every single shot is not just tedious, it creates inconsistency. A professional workflow relies on tokenization, breaking your prompts into modular, reusable components. Think of this like a chef's mise en place. You don't chop onions every time a customer orders a dish, you have them prepped and ready. In Montime's Tage, you should separate your prompts into functional categories: aesthetics, camera data, lighting rigs, and negative constraints. By storing these code snippets in a dedicated database or text expander, you ensure that every shot in a campaign shares the same DNA. If a client approves a specific golden hour cinematic look, you save that string of text as a master template. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a modular prompt construction interface. The visual should depict a central master prompt box being fed by distinct colored blocks labeled lighting module, camera lens module, style LoRa, and brand constraints. The design should look like a high-end node-based UI, sleek dark mode, with glowing connection lines indicating data flow. 8K resolution, technical aesthetic. Here is an example of how to structure a modular template for a recurring commercial client. / concept, modular prompt structure. / this is a logic structure, not direct syntax. Base _ template, subject _ action, inside, location. Brand _ look, shot on Arri Alexa 65, color graded Kodak Vision 3500T, high contrast, sharp focus. Lighting _ A, soft volumetric window light, God rays, dust motes, rim lighting on subject. Negative _ constraints, drawing, cartoon, 3D render, blurry, distorted hands, text overlays. / final prompt assembly. / a young woman drinking coffee, subject _ action, inside a modern kitchen, location, soft volumetric window light. Lighting, shot on Arri Alexa 65. Brand _ look, no drawing, cartoon. Negative. By using this method, when the client asks to change the location from a kitchen to an office, you only change one variable. The lighting, camera, and quality settings remain mathematically identical. This is how you scale production without losing the visual thread. 8.1.1 Version control for prompts. In a team environment, prompts evolve. You might tweak a lighting parameter to reduce glare, but your colleague is still using the old version. This leads to disjointed deliverables. Implement a versioning system for your text prompts, e.g., brand _ style _ v2.4. Treat your prompts like software code. If you update the master look, everyone on the team must update their copy. This discipline ensures that 5 different artists can generate assets that look like they came from a single camera. 8.2 Adhering to strict brand guidelines. Generative AI is naturally chaotic, brands are naturally rigid. A global corporation will have a brand book specifying exact hex codes, font weights, and emotional tones. They will not accept teal if their brand color is slate blue #6A5ACD. The challenge in Montime's Tage is forcing the model to respect these boundaries. You cannot simply paste a hex code into a prompt and expect accuracy. Instead, you must use a combination of descriptive approximation and image-to-image, IMG-to-IMG, anchoring. Start by describing the color emotionally and physically. Instead of just red, use Coca-Cola red, fire engine red, or saturated crimson. Combining these descriptors narrows the latent space closer to the target hue. However, For strict compliance, you must rely on post-processing or reference control. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison. On the left, a chaotic, multicolored AI generation labeled unconstrained. On the right, a tightly controlled image labeled brand compliant featuring a specific color palette of navy blue and gold. The interface shows reference image inputs and color weight sliders. Photorealistic style, infographic overlay. 8.2.1 The reference image workflow. The most reliable way to hit brand targets is to feed tage a reference image that already contains the brand palette. Even a crude Photoshop mockup using the correct brand colors can serve as a potent guide. Create a color map. Create a simple block color image using the client's exact branding. Input as control. Use this image in the tage structure input. Refer back to Chapter 4 Style Transfer Techniques. High weighting. Set the influence of this image high enough to retain color, but low enough to allow the AI to generate texture and lighting. This technique forces the AI to paint with the colors you provide. It is safer to generate a slightly boring image that hits the brand guidelines than a spectacular image that violates them. You can always add drama in post. You cannot easily fix a brand violation. 8.3 Rapid storyboarding and visualization. Before a commercial project is greenlit, it must be pitched. This is often the valley of death for creative ideas. Clients struggle to visualize abstract concepts. tage is perhaps the most powerful storyboarding tool ever created. In this phase, speed is more important than perfection. You are not generating the final assets, you are generating buy-in. Your goal is to move from a script to a visual timeline in hours, not days. Focus on vibe boards. Do not try to generate the exact actor or the specific product placement yet. Create frames that capture the mood, Chapter 4, and the lighting, Chapter 3. If the client falls in love with the atmosphere, the specific details can be ironed out later. Rapid pitch workflow ***. 1. Script analysis isolate key emotional beats, e.g., joy at sunrise, frustration in traffic. 2. Bulk generation run 4 to 8 variations for each beat using a loose, artistic style prompt. 3. Curate select images that flow together visually, even if they aren't perfect. 4. Upscale and overlay place these images into a slide deck with simple white text. By presenting a fully realized visual world, you remove the burden of imagination from the client. They no longer have to guess what moody lighting means, you have shown them. This drastically shortens the approval cycle and builds confidence in your vision. 8.4 Integrating assets into traditional pipelines. There is a misconception that AI video generation replaces the editing timeline. It does not. In a commercial workflow, tage is simply another camera, a virtual source that feeds into standard tools like Adobe Premiere, DaVinci Resolve, or After Effects. Do not attempt to generate a finished commercial in a single prompt. The text will be garbled, the pacing will be odd, and the sound will be non-existent. Instead, generate plates or layers. 8.4.1 Matte generation and alpha channels. One of the most powerful commercial workflows is generating specific elements for compositing. If you need smoke, fire, or a futuristic background, generate those elements on a black or green background within tage. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a video editing timeline interface. The visual shows multiple tracks, AI background layer, green screen actor, AI particle overlay, and text graphics. A compositing viewer shows the final merged image. The style should be sleek, UI-focused, and demonstrate the layering process. Use prompts like isolated explosion on black background, high contrast, or sci-fi city skyline at night, flat lighting for matte painting. You can then bring these assets into your compositor, apply a screen or Luma key blend mode, and integrate them with real footage. 8.4.2 Resolution and artifact management. Current generative models often output at resolutions lower than broadcast standards, e.g., 720p or 1080p. Commercial delivery usually requires 4K. You must integrate an AI upscaling step into your pipeline before the footage hits the editing timeline. Treat the raw montage output as a digital negative. It needs to be developed. 1. Denoise. Remove the AI grain or shimmer using temporal denoising plugins. 2. Upscale. Use a dedicated AI upscaler to reach delivery resolution. 3. Grain. Add a layer of uniform film grain on top of the upscaled footage. This unifies the generated pixels and hides the synthetic smoothness. By wrapping your AI workflow in these traditional post-production techniques, you create a product that feels finished, professional, and indistinguishable from high-budget VFX. The client should not look at the screen and say, "That's cool AI." They should look at it and say, "That's a beautiful shot." 8.5 Bridging the gap, using montage assets in professional VFX suites. To use generative assets in professional film pipelines, DaVinci Resolve, Premiere Pro, Nuke, creators must move beyond the flat render. Step 1. The Luma plate generation. When generating elements like smoke, sparks, or dust, use a high-contrast background. Imagine prompt, volumetric dust motes dancing in a single sunbeam, pitch-black background, 8K, sharp focus R16:9. Step 2. The compositing workflow. Import. Bring the render into your NLE, nonlinear editor. Blend mode. Change the layer blend mode to screen or linear dodge. This instantly removes the black background, leaving only the light-based effects. Grain matching. AI renders are often too clean. Apply a grain noise effect to the AI layer that matches the ISO and texture of your live-action base footage to seat the asset into the scene. Summary. Scaling for clients is about removing variables. It is about taking the magic of montage and putting it in a container that is safe, repeatable, and high quality. We have learned to tokenize our prompts for consistency, force brand compliance through reference anchoring, and treat our generations as raw materials for a compositing pipeline. You are no longer just exploring the latent space, you are mining it. You have the tools to deliver professional work that stands up to scrutiny. Now, we must look at the ethical landscape of what we are creating. In Chapter 9, we will discuss the responsibilities of the creator, copyright implications, and how to navigate the complex legal waters of generative media. Figure mindmap commercial workflow in montage, production pipeline, Phase 1, preparation, prompt library, templates, tokenization, version control, brand guidelines, hex codes -text desk, IMG2 IMG anchors, negative constraints, Phase 2, execution, pitching, vibe boards, rapid iteration, mood versus detail, generation, batch processing, seed management, Phase 3, post-production, integration, compositing, alpha mats, overlays, finishing, upscaling, denoising, grain. Application.
Chapter 9, Debugging the Dream, Overcoming Common Generation Errors. Section 9.1, Diagnosing the Root Causes of Visual Hallucinations and Artifacts. Section 9.2, Troubleshooting Plastic Textures and Oversmoothed Aesthetics. Section 9.3, Resolving Complex Spatial Relationships and Limb Rendering Issues. Section 9.4, Strategies for Handling Text Generation and Logo Placement Challenges. In Chapter 8, we scaled our operations, discussing how to build reliable pipelines for commercial clients. You learn to treat montage as a production house. But even the most robust assembly line occasionally jams. You input a perfectly crafted prompt, hit generate, and the result is a nightmare of twisted geometry, illegible text, or skin that looks like melted wax. This is the reality of working with probabilistic models. They do not understand physics or biology, they predict patterns. When those predictions fail, it is rarely random. It is usually a logical error in the semantic instructions you provided. In this chapter, we stop being creators and start being mechanics. We will lift the hood of the montage engine to understand why generations fail. We will look at how to strip down a prompt to isolate the bug, how to force texture into plastic surfaces, and how to untangle the notorious mess of AI-generated limbs. This is debugging. It is the process of turning a failed generation from a frustration into a data point that leads you to the solution. 9.1 Diagnosing the root causes of visual hallucinations and artifacts. A hallucination in AI generation is not a creative flourish, it is a misinterpretation of data. It usually happens when the model is pulled in too many conflicting directions simultaneously. We often call this token bleed. Imagine asking a painter to draw a furious, calm, blue-red sunset. The concepts bleed into one another. In Montaigne's Tage, if you describe a subject as wearing a neon green jacket and the background as a moody cyberpunk city, you might find the city itself turning neon green. The color token has bled from the subject to the environment. To diagnose this, you must engage in prompt isolation. Strip the prompt down to its noun-verb core. If the artifact disappears, slowly reintroduce your adjectives one by one. You will likely find a specific modifier that is overpowering the rest of the logic. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a prompt debugging flowchart. Visual style, clean, technical UI schematic with neon accents on a dark background. Key elements, a central node labeled glitch output, branching into 3 diagnostic paths, semantic conflict, token overload, and style contamination. Each path leads to a visual example of the error, e.g., color bleeding, distorted geometry, and a corresponding text box showing the prompt correction. Lighting, soft interface glow, highly legible text. Another common cause of artifacts is overspecification. If you use 50 words to describe the lighting, the model has fewer resources left to calculate the geometry of the face. The model optimizes for the strongest tokens. If volumetric fog is weighted higher than anatomically correct hands, you will get beautiful fog and terrible hands. Use the separator or weighting brackets, depending on your specific Montaigne's Tage syntax settings, to enforce hierarchy. Tell the model what matters most. // bad prompt, token bleed and overload. Subject, a warrior in silver armor, holding a ruby sword. Background, a crimson forest with silver leaves. Lighting, intensely bright red lighting, cinematic, 8K. // debugged prompt, separation and weighting. Subject, a warrior in silver armor, 2. Action, holding a sword. Background, a dark forest, 1. Detail, ruby gemstones on sword hilt. By compartmentalizing the concepts, you prevent the ruby of the sword from turning the armor red, and you ensure the structure of the warrior takes precedence over the color of the leaves. 9.1.1 Troubleshooting Logic Tree. When a render fails, follow this technical sequence to identify the point of failure. Issue, colors are bleeding into each other. Diagnosis, token overload. Fix, insert a hard separator between color-heavy descriptions, e.g., red car, blue sky instead of red car in front of a blue sky. Issue, subject looks like plastic or CGI. Diagnosis, default model bias. Fix, inject imperfection tokens like skin pores, slight sweat, film grain, or unfiltered lens. Issue, character face changes between renders. Diagnosis, seed drift. Fix, use a fixed seed and only change the action portion of the prompt, keeping that subject tokens identical. 9.2 Troubleshooting plastic textures and oversmoothed aesthetics. One of the telltale signs of AI imagery is the plastic wrap effect. Skin looks like porcelain, metal looks like liquid mercury, and clothes look like they were mold rather than stitched. This occurs because the model defaults to the average of its training data, and the mathematical average of 1,000 faces is a perfectly smooth, textureless face. To fix this, you cannot just ask for high quality. In fact, high quality often exacerbates the issue by pushing the model toward polished digital art. You must explicitly prompt for imperfection. Realism lies in the noise. It lives in skin pores, fabric weaves, rust, and dust. You need to introduce texture noise into your prompt to disrupt the smoothing algorithms. Think of this as adding grain to a digital photo. We need to force the model to render high-frequency details. / the antiplastic modifier list. Texture, subsurface scattering, skin pores, fabric weave, oxidation, scratches. Camera, film grain, ISO 3200, motion blur, chromatic aberration. Lighting, hard shadows, micro contrast, specular highlights. If your output looks too much like a video game render, shift your medium references. Instead of 3D render or Unreal Engine, reference analog mediums. Terms like wet plate photography, oil on canvas, or shot on 35mm Kodak Portra carry inherent texture data that the model will try to replicate. Figure, extra detailed AI-ready prompt for AI-generated diagram showing a split-screen comparison of a portrait. Left side, the plastic default, showing a mannequin-like face with smooth, glowing skin and perfect hair. Right side, the textured reality, showing the same face with visible skin texture, fine vellus hair, slight asymmetry, and film grain. Labels point to specific areas with text bubbles, subsurface scattering, microcontrast, and film grain noise. Visual style, photorealistic macro photography tutorial style. Finally, check your stylize or guidance slider. If it is set too high, Montime's Tage will adhere too strictly to the prompt's structural logic, often sacrificing texture to satisfy the shape. Lowering the guidance value allows the model a little creative freedom to fill in the blank spaces with chaotic, realistic texture. 9.3 Resolving complex spatial relationships and limb rendering issues. We have all seen it, the seven-fingered hand or the person merging into a bicycle. This happens because AI generates pixels based on probability, not skeletal structure. It knows what a hand looks like, but it doesn't understand that a thumb must be opposite the fingers. When you encounter limb distortions, the first step is simplification of pose. If you ask for the man juggling 3 chainsaws while riding a unicycle, the spatial complexity is too high. The model will collapse. Break the action down. Use the occlusion to your advantage. If hands are consistently failing, prompt the subject to put them in pockets, cross their arms, or hold an object that simplifies the geometry. Hiding the complexity is a valid directorial decision. / instead of hands creating a complex magic spell sign. / try wearing heavy leather gauntlets, fists clenched. For complex interactions, like 2 people dancing or fighting, the model often blends their limbs. Here, you must use region control or image-to-image referencing. Don't rely on text alone to separate 2 bodies. Upload a rough sketch or a stock photo that defines the separation of the figures. Use this as a structure reference in Montime's Tage. This forces the model to adhere to a predefined silhouette, preventing it from inventing extra limbs to fill empty space. If the architecture of a room looks like an M.C. Escher painting, stairs going nowhere, check your perspective keywords. Conflicting terms like wide angle, macro, and isometric in the same prompt will warp geometry. Stick to 1 lens length and 1 camera angle per generation. 9.4 Strategies for handling text generation and logo placement. Generative models are visual engines, not linguistic ones. They treat letters as shapes, not carriers of meaning. This is why generated text often looks like alien glyphs or garbled nonsensical English. While Montime's Tage has improved significantly in text rendering, relying on it for long sentences is a recipe for failure. The best strategy for text is brevity and isolation. If you need a sign that says diner, do not prompt for a busy street with a sign that says diner and people walking by. The text token gets lost in the noise. Instead, prompt specifically for the sign, or ensure the text is the primary subject of the composition. / prompting for text clarity. Subject, a neon sign glowing in the night. Text content, diner. Font style, bold sans serif typography. Composition, centered, close-up. Negative prompt, blur, typo, extra letters, Calligraphy. For logos, the challenge is maintaining brand fidelity. An AI will usually dream a variation of a logo rather than replicating it. The solution here is in painting, as discussed in Chapter 7, or compositing. Do not struggle for hours trying to get the AI to render a perfect Nike swoosh on a shoe. Generate the shoe with a blank space, then use a traditional image editor to place the real logo, or use Montime's Tage-specific logo overlay control net if available. Treat the AI as the creator of the canvas, not the typesetter. Let it generate the texture, the lighting, and the mood of the signage, but be prepared to swap the actual letters in post-production if accuracy is paramount. This hybrid workflow is faster and produces professional results. Debugging is not about forcing the tool to do something it wasn't designed for, it is about understanding the tool's limitations and finding the path of least resistance. When you stop fighting the machine and start guiding it, the errors disappear. Figure, extra detailed AI-ready prompt for AI-generated diagram showing the hybrid text workflow. 3 panels. Panel 1, raw generation showing a storefront with garbled, alien-looking text on the sign. Panel 2, masking showing a checkered transparency grid over the sign area. Panel 3, final composite showing the corrected text bakery integrated perfectly with matching lighting and grain. Visual style, step-by-step digital art tutorial layout. Figure mind map, central node, debugging AI errors, branch 1, hallucinations, subnode, token bleed, colors, concepts mixing, subnode, overspecification, too many details, action, simplify and wait prompts, central node, debugging AI errors, branch 2, plastic texture, subnode, smoothing algorithms, action, add noise, film grain, ISO, action, reference analog mediums, central node, debugging AI errors, branch 3, geometry and limbs, subnode. Spatial confusion, action, occlusion, hide hands, action, structure reference, control net, central node, debugging AI errors, branch 4, text issues, subnode, visual versus linguistic, action, brevity, short words, action, hybrid workflow, post-production overlay.
Chapter 10, Beyond the Prompt, Ethics, Copyright, and Future Horizons. Section 10.1, Navigating the Legal Landscape of AI-Generated Intellectual Property. Section 10.2, Ethical Considerations, Transparency, Deepfakes, and Creator Responsibility. Section 10.3, Developing a Unique Directorial Voice in an Automated Ecosystem. Section 10.4, Future-Proofing Your Skills as the Montage Platform Evolves. In Chapter 9, we acted as mechanics, rolling up our sleeves to fix the broken gears of generation errors. We learned that when the machine fails, it is a logic problem to be solved. But what happens when the machine works perfectly, yet the result creates a problem outside the software? This chapter steps away from the command line to address the legal frameworks, ethical boundaries, and artistic philosophies that will define your career in the age of AI. Note on visual assets. To demonstrate the versatility of generative pipelines, all visual examples and cinematic plates included in this volume were synthesized using Google Gemini 3.0 and Google Nano Banana. These tools were selected to showcase high-fidelity texture rendering and complex spatial composition, proving that the directorial principles taught in this book are transferable across the industry's leading generative models. We have reached the point in our journey where technical proficiency meets professional responsibility. You now possess the power to generate photorealistic imagery, clone voices, and synthesize video that rivals reality. This power does not exist in a vacuum. As you master Montime's Tage, you are no longer just a user, you are a participant in a global conversation about the nature of creativity. This chapter steps away from the command line to address the legal frameworks, ethical boundaries, and artistic philosophies that will define your career in the age of AI. We are moving from asking how do I make this, to asking how do I own this, and where is this technology going? 10.1 Navigating the Legal Landscape of AI-Generated Intellectual Property. The most common question from clients is not can you make it, but do we own it? The legal landscape regarding AI and copyright is volatile, evolving with every court ruling. However, as a professional using Montime's Tage, you cannot afford to wait for the dust to settle. You need a workflow that protects your work today. Current legal guidance, particularly from the U.S. Copyright Office, emphasizes human authorship. A raw generation from a simple prompt is generally considered to lack the human creative spark necessary for copyright protection. It is viewed similarly to a photo taken by a monkey, nature, or the machine did the work, not a human. To protect your intellectual property, you must move beyond being a button pusher. You must document the human intervention involved in your process. This is where the iterative workflows we discussed in Chapter 7 and Chapter 8 become your legal shield. Figure, flowchart diagram illustrating the chain of custody for AI art. Left side shows raw output, unprotected. Right side shows human intervention layers including in-painting, compositing, color grading, and manual overpaint. Arrows indicate that copyright viability increases as more human steps are added. Style, clean, corporate infographic, vector style, blue and gray color scheme. The documentation protocol. When working on commercial projects, treat your generation process like a science experiment. You should maintain a chain of custody for your assets. This proves that the final image is not just a random lottery win, but the result of specific, directed creative choices. You must be able to show that the AI was an assistive tool, like a camera or a paintbrush, rather than the sole author. Recommended documentation structure. The seed log. Keep a record of your initial prompts and the specific seeds used. The iteration history. Save the intermediate steps, the rejected drafts, the in-painting masks, and the compositing layers. The post-process layer. Clearly distinguish between the raw AI output and the manual work done in Photoshop, Premiere, or DaVinci Resolve. Licensing and training data. Another critical aspect is the source of the generation. Montime's Tage offers various models, some trained on public domain data and others on closed datasets. If your client requires absolute indemnification, ensure you are using a clean model checkpoint within the platform. These are models trained exclusively on licensed or public domain imagery. While they may sometimes lack the wild creativity of scraped models, they offer the safety required for enterprise contracts. 10.2 Ethical considerations. Transparency, deepfakes, and creator responsibility. As a director using Montime's Tage, you are a trusted manipulator of reality. In traditional filmmaking, audiences suspend their disbelief willingly. In AI generation, there is a risk of deceiving the audience unwillingly. The uncanny valley is no longer just about visual aesthetics, it is now about trust. If an audience feels tricked, believing an AI spokesperson is a real human, or a synthesized location is a real place, you erode the relationship between creator and viewer. The transparency standard. Ethical prompting isn't just moral posturing, it is brand safety. We recommend a policy of contextual disclosure. You do not need to slap a watermark on every frame of a fantasy music video, but for documentary, news, or corporate communication, transparency is non-negotiable. Consider embedding disclosure metadata directly into your files. This is a practice that future-proofs your assets against accusations of disinformation. Creator, studio name. Tool, Montime's Tage version 4.2. Generation_type, hybrid composite. Disclosure, AI-assisted imagery with manual refinement. Policy_compliance, C2PA standard. The deepfake red line. The power to clone faces and voices is available within the Montime's Tage ecosystem. Chapter 5 taught us how to maintain character consistency, but that same technology can be misused to impersonate real individuals. As a professional, you must draw a hard line. Never clone a likeness without explicit, written consent. The reputational damage of being associated with non-consensual deepfakes will end a career faster than any bad portfolio piece. We are entering an era where digital likeness rights will be as standard as appearance releases. If you are generating a digital actor based on a real person's data, treat that data as you would a hazardous material, Handle with extreme care, secure storage, and strict access limits. Figure: conceptual illustration of a digital twin agreement. A split screen shows a human actor on the left and a wireframe AI mesh on the right. A glowing digital contract connects them, highlighting icons for consent, usage rights, and time limits. Lighting is dramatic, teal and orange, emphasizing the bridge between organic and digital. 10.3 Developing a unique directorial voice in an automated ecosystem. When everyone has access to the same Make It Cool button, cool becomes a commodity. We are seeing a flood of technically proficient but artistically hollow content. The saturation is high, but the competition for voice is low. Our value as a creator is no longer your ability to render a realistic texture, the AI does that for free. Your value is your taste. In an automated ecosystem, your human moat is the ability to reject generic probability in favor of intentional art direction. By focusing on directorial logic rather than just syntax, you invest in skills that are software update proof. Syntax has an expiration date, visual literacy and narrative structure are permanent. The curator's mandate. In the past, a director was defined by what they could build. In the AI era, a director is defined by what they reject. You must become a ruthless curator. The machine will offer you 1,000 variations. Your job is to know why 999 of them are wrong for the story. To develop a unique voice, stop prompting for styles, in the style of Wes Anderson, and start prompting for feelings, lighting ratios, and compositional theories. Don't borrow a look, build one using the fundamental mechanics of art. Hybrid workflows as a style. The most distinctive work currently coming out of the Mon Times Tage community is not pure AI. It is hybrid media. This involves mixing traditional photography, 3D modeling, and hand drawing with AI generation. For example, sketch a rough composition on a napkin, scan it, and use it as a ControlNet input, as discussed in Chapter 6. This ensures the composition is yours, not the model's. The AI becomes a renderer, not a director. By injecting your own flawed, human inputs into the precise digital system, you create a friction that results in a unique aesthetic signature. 10.4 Future-proofing your skills as the Mon Times Tage platform evolves. This book is titled Prompt Engineering, but I will let you in on a secret. The term prompt engineering has an expiration date. As natural language processing, NLP, improves, specific syntax hacks and magic words will become obsolete. The platform will eventually understand Make It Look Sad without you needing to specify volumetric lighting, 8K, blue color grading. So, if the syntax is temporary, what skills are permanent? The pivot to directorial logic. Future-proofing means investing in skills that transfer between model versions. A good composition follows the rule of thirds or the golden ratio regardless of whether you are using Mon Times Tage V1 or V10. Color theory does not change with software updates. Focus your learning on these 3 pillars. Visual literacy. Understand why an image works. Study cinematography, not just prompt libraries. Narrative structure. AI can generate a scene, but it struggles to generate a story arc. The ability to link images emotionally, Chapter 5, is the ultimate human moat. Technical integration. Learn how to pipe AI outputs into other software, After Effects, Blender, Unreal Engine. The person who can integrate AI into a pipeline is infinitely more valuable than the person who just generates JPEGs. Figure: a timeline diagram titled The Skill Evolution. The timeline progresses from 2023, syntax specialist, icons of code and keywords, to 2025, workflow architect, icons of nodes and pipelines, to 2027, creative director, icons of storyboards and human emotion. The background features a subtle gradient moving from technical grid lines to organic brushstrokes. The infinite canvas. We are standing at the threshold of a new medium. Just as the camera did not kill painting but liberated it from realism, AI is liberating filmmakers from the constraints of budget and physics. You have the tools. You understand the mechanics of motion, the logic of consistency, and the necessity of ethics. The prompt is just the beginning. The rest is up to you. Figure Mind Map Chapter 10, Beyond the Prompt, Ethics, Copyright, and Future Horizons, Legal Landscape, Copyright Challenges, Human Authorship, USCO Guidance, Monkey Selfie Analogy, Documentation Protocol, Seed Logs, Iteration History, Post-Process Layers, Licensing, Clean Models, Indemnification, Ethical Considerations, Transparency, Contextual Disclosure, Metadata Embedding, Trust Economy, Deepfakes, Consent, Likeness Rights, Brand Safety, Directorial Voice, Curation. VS Creation, The Art of Rejection, Taste as Skill, Hybrid Workflows, ControlNet Inputs, Hand-Drawn Sketches, Mixed Media, Future-Proofing, End of Syntax, NLP Improvements, Intent versus Keywords, Permanent Skills, Visual Literacy, Narrative Structure, Pipeline Integration. 10.5 Content Authenticity and Copyright Protection. As of 2024-2025, pure AI output is difficult to copyright. To protect your commercial work, establish a chain of custody. The seed log, document the specific seed numbers and prompt iterations used to create a character. This proves creative intent. C2PA metadata. Use tools like Adobe Content Authenticity to embed metadata into your final export. This tags the file as AI-assisted rather than AI-generated, which is crucial for brand transparency. Hybrid verification. Keep your original sketches or plate images, the human-made inputs. Showing the evolution from a human sketch to a Montime's Tage render is the strongest defense for IP ownership.
Chapter 11, The Montime's Tage Lexicon, a Master Dictionary of Keywords. In this final chapter, we move beyond structural grammar to provide a high-fidelity dictionary of specialized keywords. These terms are the technical shorthand the Montime's Tage engine uses to parse specific visual realities, from optical physics to historical film textures. Using these precise keywords reduces statistical variance and ensures your directorial vision is translated with surgical accuracy. Section 1. Optical and Camera Hardware. These keywords define the glass through which your scene is captured, controlling how the engine simulates depth, scale, and perspective. Keyword: anamorphic lens. Function: instructs the engine to mimic the optical characteristics of anamorphic glass, including horizontal lens flares and oval-shaped background blur, bokeh. Full prompt: imagine prompt, a weary cyberpunk detective leaning against a brick wall in a rain-slicked neon alleyway, shot on anamorphic lens, oval bokeh, horizontal blue lens flares, cinematic lighting var 2.39:1. Keyword: macro lens. Function: forces a tight focus on microscopic details with an extremely shallow depth of field, used for high-fidelity texture rendering. Full prompt: imagine prompt, an elderly clockmaker's hands assembling microscopic gears, macro lens, 85mm, extreme close-up, shallow depth of field, f1.8, focus on textured metallic surfaces. Keyword: Dutch angle. Function: tilts the virtual camera on its x-axis to create a sense of disorientation, tension, or psychological instability. Full prompt: imagine prompt, a corporate executive panicking in a glass boardroom, Dutch angle, 15-degree tilt, looking up from a low-angle worm's eye view, harsh high-contrast lighting to suggest corruption. Keyword: IMAX 70mm. Function: signals the engine to render with maximum dynamic range and massive detail, simulating large-format film scale. Full prompt: imagine prompt, a solitary lighthouse on a jagged cliff surrounded by violent hurricane waves, IMAX 70mm, sweeping panoramic landscape, hyper-detailed textures, massive dynamic range dar 16:9. Section 2. Lighting schemas and atmospheric effects. Light is your primary tool for sculpting mood and separating your subject from the digital background. Keyword: rim lighting. Function: creates a thin line of light around the edges of a subject to pop them off the background and add a professional, high-production look. Full prompt: imagine prompt, a futuristic warrior standing in a dark void, intense volumetric rim lighting, cyan backlighting, sharp separation from the background, cinematic atmosphere. Keyword: gobbo effect. Function: projects patterned shadows across a scene, goes before optics, adding complex texture to flat surfaces. Full prompt: imagine prompt, a portrait of a mysterious woman in a noir office, harsh sunlight streaming through Venetian blinds, gobbo effect, striped shadows across the face, dust motes dancing in volumetric light shafts. Keyword: chiaroscuro. Function: employs strong, dramatic contrasts between light and dark to create a sense of volume and three-dimensional depth. Full prompt: imagine prompt, an elderly scholar reading a leather-bound book, chiaroscuro lighting, single candle light source, deep dramatic shadows, high contrast, 17th century oil painting style. Keyword: subsurface scattering. Function: simulates how light penetrates and scatters inside semi-translucent materials like skin, wax, or marble to remove its plastic look. Full prompt: imagine prompt, close-up portrait of a young woman in soft natural light, subsurface scattering on skin, realistic skin pores, visible fine hair, shallow depth of field, f1.2 no plastic skin. Section 3: Film stocks and textures. Defining the medium ensures your output has the organic glue of chemical photography rather than the sterile perfection of raw AI pixels. Keyword: Cinestill 800T. Function: mimics high-speed tungsten balance film, known for the halation effect, red glow, around bright light sources in night scenes. Full prompt: imagine prompt, a 1970s detective car chase in a rain-slicked city at night, shot on Cinestill 800T, red halation around neon signs and street lamps, visible film grain, cool tungsten color balance. Keyword: Technicolor. Function: invokes a vintage aesthetic characterized by hypersaturated primary colors and a vibrant, dreamlike quality. Full prompt: imagine prompt, a 1950s garden party with vibrant floral dresses, Technicolor process, hypersaturated primary colors, bright optimistic lighting, vintage 35mm film aesthetic. Keyword: bleach bypass. Function: produces a high contrast, low saturation look common in gritty war films or serious dramas. Full prompt: imagine prompt, a soldier standing in a muddy trench during a storm, bleach bypass grading, high contrast, low saturation, gritty metallic texture, desaturated color palette. Keyword: ISO 3200, film grain. Function: manually introduces digital noise into shadows to disrupt smoothing algorithms and provide tooth to the image. Full prompt: imagine prompt, an underground jazz club with a saxophone player in shadow, low light, ISO 3200, heavy film grain, monochromatic black and white, Ilford HP5 style. Section 4: Technical mechanics and flow. These keywords control the fourth dimension, the physics and temporal flow of video generation. Keyword: translation, tracking the dolly. Function: defines movement where the camera moves through space, causing objects closer to the lens to move faster than the background, parallax. Full prompt: render video prompt, the weary cyberpunk detective walking through a neon-lit alleyway, camera _move tracking _forward, intensity 3, smoothness high, parallax _depth max. Keyword: time dilation. Function: instructs the engine to generate in slow motion, increasing consistency by reducing pixel change between frames. Full prompt: render video prompt, the heavy velvet banner flapping in a violent gale, rigid folds, time dilation 0.5, shutter angle 180, intensity 2. Keyword: cyclic motion. Function: encourages the engine to create movements that return to their starting state for seamless loops. Full prompt render video prompt: the futuristic glowing artifact rotating slowly in mid-air, pulsing neon lights, loop_mode, seamless cyclic_motion, orbiting seed 1 2 3 4 5.